All right, this is number 8. We're going to be using the rectangles under sine of x. So right here, this one to start. And we're going to estimate the area under the curve. And so using rectangles are base times height. So our base is going to be this distance, and our height will be this distance of the first rectangle right here. And so to find the base, I've got 4 equal intervals under pi. And so if I take pi, divide that by 4, each of these change in x is going to be my base. Then I have to multiply it by the height. The height is dictated by the function, which is sine of x. And so each of these rectangles will have this as the area formula. Okay, so the area formula for one rectangle will be pi over 4 times sine of x. Now I have 3 rectangles that I see here. I actually have a 4th here, but that's going to have an area of 0. All right, so let's do this. The area estimate for under the curve, for this first yellow one, I've got pi over 4 times sine of pi over 4. And the way I know this is pi over 4 is I go from 0 plus pi over 4, and that gives me that value. And then I'm going to do the next one. So before I do that, let's highlight that in yellow. Let's go with green for the next one. So I've got plus. This interval right here is still pi over 4. And then the height will be the sine of pi over 2. The value here, this is the height of the function. Then for the third rectangle, let me like this. The third rectangle is going to be pi over 4 again, base times the height, and that's going to be sine of 3 pi over 4. Yes? So the question is, how did I get, let's say, this piece right here? Okay, so the function is dictating the height here. So this is your height of all of these rectangles. And the height of this rectangle is the height of the function at 3 pi over 4. The height of this rectangle is the height of the function, y equals sine of x, at pi over 2. And the height of this rectangle is sine of pi over 4. And so that this is going to be my base times height, base times height, and base times height. Okay? All right. So now we evaluate each of these. So I've got pi over 4. Then sine of pi over 4, which is root 2 over 2. Then pi over 4. Sine of pi over 2, which is 1, plus pi over 4. Sine of 3 pi over 4, which is root 2 over 2. And when I evaluate or simplify, I've got root 2 over 2 twice, so that's just root 2. Plus 1, and then multiply that by pi over 4. So I pulled out the pi over 4. And this you can plug in your calculator to get a decimal answer. So what is going? There we go. All right, so we're looking at a function 6x minus x squared, and they're talking about secant lines. Secant lines are lines that go through 2 points in the function. All right, so they're defined by 2 points on the function. So the first part, graph f, and the secant line passing through the point 2, 8, which I have marked in red. And let's do the second point at 3. I'll start with that. I'll mark that one in blue. So the secant line here, tools, pen modifier, here we go. So I've got this line as the secant line. And so then with that line, I can then calculate the slope in part B. So let's go ahead and do that. Slope, ooh, still have my pen modifier on. So slope is equal to, since I'm using this point for x, so I've got point 3, and then if I plug 3 into f of x, I have 18 minus 9, which is 9. Making sure I'm thinking correctly. All right, then we've got my change in y, which is 9 minus 8, or 1, divided by 3 minus 2, which is also 1. So the slope there is 1. Okay, so that's b. And then use the results to estimate the slope of the tangent line. Well, let's find the other two as well before we do that. So the process of finding the slope is going to be exactly the same. We're just using 2.5 and 1.5. So next, I'm going to find 2.5. So I'm coming over here, 2.5. There's this point, and I'm still going through the red. So I need my pen modifiers again. And I'm going through this line. Oh, didn't grab it, did I? It's pretty straight for not having it. Let's see. There we go. That's better. All right. So that is getting closer to the slope. It's a better approximation than the one was with the blue line. Would you agree? All right. So then if I did that with the other, let's see, I'll grab a different color, and 1.5. So I've got 1.5. It's about here. And I'm still on pen modifier. Let's do that. 1.5 there. And goes through that. And that. All right. So next, I'm going to go ahead and find the slope of those two. Let's take this, get rid of it. So the slope between, let's see, 3, 9 and 2, 8 was 1. We have the point, let's see, this is going to be 2.5 and then 2, 8. If I plug in 2.5, what do we get? We have, I should have done this before I started recording, huh? What is it? 8.75. Thank you. Saved me. All right, and then we're going to do the same thing with 1.5. 6.75. And 2, 8. Okay, so now I calculate the slope between those two, and I may need a little help. We've got 8.75 minus 8, which is 0.75. And then 0.5, or 2.5 minus 2, 0.5, which gives me what? Negative 3 halves? No, it should be positive. 3 halves, all right. All right. So positive 3 halves. All right, and then the next one, I'm going to take 8 minus 6.75, that's 1.25, and 2 minus 1.5, it's 0.5, and this should be a positive slope. So what is this? 5 over 2? All right, so this is 5 halves, 3.5, and then 1. So as I go this direction, I'm getting steeper slopes. So I go from 1, 1.5, and then 2.5. So where is this going to lie? Where is the actual slope, the slope of the red dot, going to lie? It should lie in between those two, so right around 2. Right.